Okay, no, I'm going to be quick. Yeah, I want to thank the organizers also for this fantastic 3 days meeting. It's really a nice mixture between very good science and good memories for Paul. So I'm going to talk about the South China Sea. So we saw that this edge of the continent at the beginning of the meeting, and so when I arrived in Paul's lab, I was in DEA, so I was master's degree M2, like we say now, and Gilles had already produced these magnificent plasticine models, and so the main structure of the model with the extrusion of different slices of Asia was already published. Or was like already written, and as well, no. As Satish said, the Jean Charcot was doing like Ifremer decided to go around the world with the Jean Charcot, and because that's what happened at the time. It was like Ifremer decided where to send the ships, and then Ifremer chief scientists went on board and invited researchers. That's how it happened. And so the South China Sea is actually at the middle. It's not only at the edge of the continent. It's really a complex area within at the junction of three major plates: Eurasia, the Philippines, and Pacific, and Indo-Australia. And in more details, it has a very specific shape with a very narrow western margin, a very wide northern and southern margins. It had been shown already that the geology of the southern blocks in Palawan was similar to southeast China. And of course, the ocean crust, the ocean lithosphere, is currently subducting under the Philippines. So it's a very complex area. And of course, all this bathymetry, which is partly derived from the satellite altimetry, was not available at the time. It was only available starting in 1997. So there was a lot of different models. When I started with various ways to have the idea of a proto South China Sea subducting under Borneo, and just some slices of continent migrating south until they collide with Borneo. So that was all these authors. And of course, Paul's ideas were completely opposite, and the driving force in Paul's model was the extrusion of the different slices. And so these are the results of 3 to 4 years of work with Paul and with Philippe Patria at IPG. Other models include just back arc basins from with the Pacific. This is more recent. And there's even a model suggesting that there's a hotspot under Hainan, and that's the driving force for the opening of the basin. So yeah, there's a lot of imagination in the South China Sea. So there's the Charcot went from there was a first leg in '85 from Manila to Manila, where we sort of crisscrossed the relict spreading center in the South China Sea. This had been identified by work on the magnetic anomalies by Taylor and Hayes. So we knew where the axis was. And Paul was not on board. I was just I didn't go in the field in Asia with Paul, but I was thrown on the Chaco and said so. And the Jean Aubin was the head of the DEA at the time, and he said it was a little unfair for the other DEA interns, because I had to go to a cruise, and some of the others only had to read papers and then work on that. So we went, so we went across the axis of the South China Sea, and then there was a what they call the valorized transit, a transit valorisé, which was supposed to go from Manila to Jakarta, and actually in Jakarta the government changed. It was in '85, and the two cruises which was supposed to happen off Indonesia afterwards were cancelled. And we waited for about a week just off Jakarta, and the IFRMER decided to send the ship in Singapore, so that became Manila, Singapore. Of course, I was very happy to have Paul with me to discuss science. It was so special, and Paul was so furious because he had many appointments, of course, and he wanted to go back to France, and it took a call to Jean Franchetot to send us to buy new plane tickets, because the industry was not very reactive at the time. So anyway, so Paul spent like 10 days on the Chaco at that time, plus maybe 5 days just waiting for a solution. But we managed to work and to have beautiful results, because the Chaco was equipped with C-beam swath bathymetry, and it was a very narrow swath, but it was still 3D bathymetry compared to all the previous studies, which had only single beam bathymetry. So we could identify that all the latest events in the basin had an orientation with northeast southwest normal faults, and we could identify also beautiful tilted blocks that are typical of slow spreading mid-ocean ridges. Then I worked a lot on the magnetic anomalies with Philippe Patria, and the quote from Philippe Patria is that the magnetic anomalies were very crappy compared to the big oceans, but we managed to identify anomalies on either side of the mid-ocean ridge. We fit the anomalies on either side and calculated poles of rotations, and that was the first real estimates of poles of rotations in the South China Sea, and identifying a ridge jump and then the propagation of the mid-ocean ridge to the southwest, and so all that was brand new compared to the previous studies, and of course this was completely compatible with the motion of the major faults in Southeast Asia, especially the Eilach and Red River, as a driving force for the extension and the spreading in the South China Sea. And so we published the paper in '93, and that was almost that was very quiet for me for a long time. But then the Chinese decided to fund drilling expeditions. So it was there were 3 IODP expeditions: 349, 367, 368. One in in the oceanic basin to try and date to confirm the age of the basin, and to understand all the kinematic evolution of the basin. And we drilled a site close to the axis in the east, two sites in the southwest, and two sites in the north. But we didn't manage to drill the oldest basin as we planned. We had some technical problems at the time. The other expeditions were focused on the northern margin. So there was at the time some seismic lines, and actually the basin I didn't mention, but the basin has a lot of oil and gas. So there was a lot of prospects for oil and gas, and the Chinese oil companies provided some of the seismic lines. So at some point, because of generator Manachar influence, there was some idea that maybe there was some mantle outcrops along the southern margin of the basin. So we had to drill and see what was happening. So these two expeditions had a major transect across the margin. And so the nice results was for the first expedition in the ocean basin was to confirm the age of the age estimated by the magnetic anomalies. So the drilling was just off the axis to the north, and at that site we drilled a lot of sediments and then some volcanic clastics layers, and then we reached the basalts. And within the basalt layers, we had the chance to drill a layer of clay stones, and within these clay stones there was this radiolarian, which is very, very important for me because it happened to live between 17.5 and 15 million years. And so it was really a confirmation of the age of the end of the spreading, near 15 million years, as I estimated from the magnetic anomalies. And then there was some absolute dating of the basalts using argon-argon dating, also confirming the age of these basalt layers. In the southwest, we had some basalt basement reached just south of a little bit south of the relict spreading center, and same from the biostratigraphy, we estimated the age of the basalts, the age of the crust around 17 to 21 million years, and absolute dating from the basalts were 17 to 18 million years. And given the distance between the drilling site and the relict spreading center, it was also confirming the age of the end of the spreading in the southwest subbasin. And then in the east, we also could give an age to the major volcanoes that are very specific to the and kind of disrupt the ridge axis, the former ridge axis, with huge volcanoes, and some of the volcanic clastic were drilled and confirmed the age of 18 to 13 million years for these events. And so in the north, we had a whole transect of drilling sites across the margin up to the oceanic crust, actually. And so the site 1500 drilled, we reached the basalts, and so we could confirm the location of the continent-ocean boundary. And confirm also the age of the opening. So at site U1435 along the northern margin, we could confirm the going from lacustrine deposits to marine deposits around 33 million years. And then we could identify also from the drillings on the transect a major uplift event around 26 to 23 million years, especially at site 1501. So then, since then, this has been there has been a lot of observations. Of course, the satellite altimetry has brought complete maps of the ocean and of the basement. So and also the change in the United Nations rules for to define the EZ brought all the countries to map their potential EZ. So we have lots of bathymetric data. A major set of papers, actually from Hall and Bredfeld and Henning Bredfeld showed that the major sediment layers, the Crocker Ranger layers, which had been interpreted to be an accretionary prism in the models involving the subduction of the Proto-South China Sea. Well, these sediments were shown to have been derived from Sunderland, so from the north, and not without the necessity to have an accretionary prism. And then there's been a lot of tomography images, especially in this Wunsupi paper, showing lots of slabs everywhere except beneath Borneo. So confirming that that there was no real slab under Borneo that could have driven the extension in the South China Sea. They found some slab in the north, and they found a slab corresponding to the current subduction under the Philippines, but but there's nothing really significant under Borneo that could correspond to the Proto-South China Sea. And then this also, if we want to reconstruct the whole area, the observation on land. So this is the observations from Robin at the time, with motion along the Wangchao fault and the Three Pagodas faults, with ages of the left lateral strike slip motion between 35 and 26 million years. And of course, the observations by Paul and Hervé Leloup on the Afar and Red River shear zone fault system, with major left lateral shear along these faults, which have been dated also from 32 to 19 million years, so that the rate of motion along the fault are compatible with the rate of opening of the basin. So it all fits together, and from the development of the margin with the subduction of the Paleo-Pacific a long time ago, all the ages are compatible with the model of Paul, and including the direction of the opening defined by the texture of the abyssal hills in the bathymetry, which so I made some reconstructions, but only in the oceanic basin. So the driving force in South China Sea is definitely related to the major faults in Asia. So, and this is the last sort of the only field trip I had with Paul and Kevin, actually. And the only real shear zone I saw was on sail on the edge of the road, and Paul asked for all the people. It was beautiful sculptures, and they didn't want to know. They didn't want to let us know where the marbles came from, but it was fantastic. So thank you for that.